correlation. Correlation is done basically to look at the relationship between two variables and the direction at which the variables are moving. For instance, if you have one variable, let's say you have AMR genes, antibiotic resistant genes, and then plasmid that you have extracted. You want to know whether when the bacteria is harboring more plasmid, do we also have more AMR genes? Because these plasmids move the AMR genes around. So is there any correlation between number of plasmids and the number of AMR genes that you can find in a bacteria? So you want to find out whether when one increases, the other one also increase, or when one increases, the other one decreases, or when one increases, nothing happens. So we have uh, positive correlation, negative correlation, no correlation. We have strong correlation, we have weak correlations. And of course, we also have different ways through which we can do this. Now, I'm going to take us through all of the ways. I have already done that. So I'm deleting all of this. And then we will look at them one after the other. And then at the end of the day. So first of all, I have the question here. Is there a relationship between AMR gene count and plasmid count? So to those of us, if you are working with, if you are into microbiology or molecular biology, you should understand this. So this is the number of AMR genes, and then these are the plasmids. So we want to know is whether plasmid or AMR genes is a predictor of plasmid. So X is the predictor, Y is the response. So we want to calculate the correlation. Now, the first method we can use is the Correl. So I can use the Correl function, and then it asks me of my array one. This is my array one. I'll put comma there. This is my second array, and then I'll just close it and tap enter. So I have my correlation very strong. That's about 99%. If I click here, then that will give me almost 100%. Then if I come here, it's the same thing. We can use the same Corel function. Then we simply pick the first range, then comma the second range, close it up and tap enter. Then that's also a very strong correlation, positive correlation. Now let's come to look at another set of bacteria. So this is antibiotic dosage as bacterial growth. We want to check whether the more you are increasing the antibiotics, the dosage to a patient, does it lead to more bacteria growing or the bacteria growth reduces? Bacterial growth simply means the number of bacterial species or strains that are found within the body. So we say what is the Corel? Then we simply pick the first dosage as our first variable. We put comma, select the other one, close it up and tap enter. So there's a negative correlation, which means an increase in one more dose of antibiotic would result into what a reduction. Now, let's also check another one here. So we also use that same function, the Corel function here. Like now, you should know that you put comma, then select the second range, and then in that order. So here we have a negative correlation, but practically like no correlation, about 12%. And so that is it. So we can have, this is the first method through which we can actually do the correlation. Now, the second method I'm going to do is where we use the data tab, and then we are good to go. The data tab, we simply come to the data, come to the analysis portion, and then we look for this analysis toolbar, then come and click on correlation, come to this point, and then simply delete whatever that is inside. Also delete whatever that is inside here. And that way we are good to go. So we're going to come here and then our input range. Remember in correlation, the input range will take everything. So I'm just going to highlight together with the headers. Come and click on column, click on label as headers, and then that's okay. I think I highlighted in a different place. You have to make sure the cursor is blinking on the input range before you highlight the two variables you want to check the correlation. And then we come here, output range. Where do you want the output to appear? I want mine to just appear where I have clicked, and that's all. Make sure you tick the labels in the first row as headers. and then in that order. Then I'll just click OK. And then that's my correlation over there. That will also give me the same thing, like the 99 that we calculated earlier. So let me do one more, and then I think that will be fine. So like what I said is, you simply come to the data tab, then you come to data analysis, you see correlation, just click on OK. And whatever that you are seeing here, you cancel it over here to cancel it. And now we come, where's our input range? For correlation, we select the two variables at the same time. Make sure the input range, click your cursor, let it be blinking over there. Select it with the headers. And then make sure you group by, you check it. Labels in the first column. It means if the column has labels, has headers, like AMRG is a header, plasma is a header. So you have to make sure you tick the labels in the first row as headers. Output range, you want it to appear here. I'll just click, I'll just say, oh, sorry. Made a mistake here. Whilst it was there, I needed to finish this highlight. The output range, make sure you click and your cursor is blinking in the output range tick box. So we want the output range to appear here. And everything is fine. Click OK. So it will give you your correlation. This is the correlation. This one is not. This is the actual correlation. So 99%. So basically, this is the other way through which we also do correlation. Now, let me delete that, and then we go to the third way of doing correlation. The third way is by using the graphical method, and by far, that's the most one that is good for publications. That's good for publications. And with that one, simply highlight the two variables. These are isolates, so those ones, they are just numbers. They are index numbers, so we don't need it. So we come and highlight the two variables, x and y, and then we go to our insert tab, then come to the chart sections. Remember, when we say insert tab, it doesn't mean you're going to see the word tab. All of these are called tabs. So when I say insert tab, it means I am looking at a tab that is called insert. So that's insert here. Then under the insert tab, come and look for charts, chart group. This group is called charts. Then you will see the scatter just on top here. Click on the drop down arrow and you can select the scatter. Then you are good to go. So when it happens like this, maybe narrow it up. I just want us to be able to have. So you see that the response variable, which is y, is always on the top here. Now let's remove these grid lines. So you click on this plus, come and uncheck the grid lines. Then we add a trend line to it so we can see the trend, so we can see the correlation and how it is going. But that's not all. The next thing is to display something we call the equation of the line, and of course the R squared. The R squared tells you the strength of this particular correlation. So now we come to this trend line, click the arrow and come and click on more options. Go all the way and you will see something like display equation on the chart and then display the R squared value. Now when you do that, then you can just close this and then see. Now we have the equation of the chart is here, and then the R squared is actually 0.987. This is the strength of the correlation. So it means the model that we are predicting here, the probability that if the AMR genes increase, the number of plasmids will also increase. What is the strength of that particular model? It gives us the what is it? That's the R squared. The R squared is also like telling us that whatever variation we are seeing in one can be explained by the other one by about 98%. That's what the model accuracy is saying. And so we display it over here, and then that is it. So we can do that for the rest if we so wish. So I could have come here again, highlight the two, come to the insert tab, come to the chart group and select this, select the bubble, then come to this point. Whilst the bubble, if it is not there, click inside the chart. Then you can come here and tick also 98%. And so we can, this also is also correlation, but it's a little bit more like much more of like It gives you more insight into your correlation than just the ordinary figure. And so this one is good for. So if I were to answer the question of what's the relationship between the number of AMR genes that I obtain and then the plasmid, then I can simply display this, and this is the relationship. It's actually a positive relationship, meaning the more what I see plasmids, then the probability that the bacteria has a lot of AMR genes that can resist antibiotic effect is high. And then what is the model accuracy? It's about 98.8%. That's the R squared here. So that is it. Then maybe if we check one more here, then we will notice. So this time around, I will just be quite fast about it. And so this is negative correlation. I remove my grid lines, come here. Then I'll simply come to more and then display my equation. And that's all. Close this particular chart, reduce this to a small size, and then I'm able to get my correlation, and then my R squared. It's actually a negative correlation. As you can see, the graph is negatively sloping, and you can check the intercept, which is also a negative. The intercept is negative. If the intercepts were not negative, well, sorry, the coefficient. Sorry, I'm saying coefficient, not the intercept. Coefficient. The coefficient were not negative. So that's it. Then we have another one here, the very last one here. You might see that the correlation is quite weak, very, very weak. So let's highlight it, then come to this point, and then we simply can do this. Let's reduce it to a very small size, and then bring it down a little bit, like this. Then I'm going to remove the grid lines, as usual, may add a trend line. So you can see that there is practically no correlation. Like when the trend line is almost 180 degrees, it means there's no correlation. There's just actually no pattern. And so we can also as well display the, what is it, the equations if we so desire, and then everything will be there. So basically, this is how we actually handle what is the correlation in the three methods. You can use the data tab, you can use the graphical method, you can also use the Cora function to be able to. But I recommend this particular one because this one is much more explanatory and has more what is it inside. But in all of this, correlation doesn't just end there. In fact, if you are dealing with correlation and then your sample size is that small, like what I'm working with now, just 5, sample size of 5, it doesn't, you may think that you have strong correlation, but this could be by coincidence. It might not be significant. So, and after correlation, how do you calculate the significance of the correlation that you have just calculated? Now, I shift you to a different portion and then we learn that quickly. So let's come here. I have another set of data which is here. Now, after I have calculated my correlation, I need to be able, so this is my correlation, which is R. This is my sample size. I need to calculate my t statistic and I need to also calculate my p-value. And so I'm going to do this. And to be able to calculate your t statistics, then you need the R, which is the correlation, and then you need n, which is the sample size, and you need degree of freedom. I forgot to add that degree of freedom. That is always equal to the number of samples minus 1, and then that is it. So here, if we are able to, we should be able to come out with this particular calculation. So let's start. And we start by saying that we want to calculate the correlation. And so we can use the function. If you don't want to use the function, you can use the graphical method and extract your correlation. So whichever way, if we're going to, but because some of you don't have the function, I will use the the data tab. So I'll come to my data tab here, and then I will simply click on correlation. I'm removing the whole of whatever that is found here. And then I remove everything that is found here. And then again, let me come to this side. Then it's correlation. So I'm highlighting everything here. And that's it. Everything is set properly. So I'll just click here and say that I want my results to appear over here. And that's it. I click OK. And then my correlation is 0.99. And that's it. So I will come here and I will say my R is equal to So R, I'll put it here, 0.99, 0.99. Then, so I don't need this table any longer. The next thing is my degree of freedom. Degree of freedom is the total number of samples we have. So it's 1, 2, 3, 4, 5 in each group minus 1. So it's 5 minus 1. What if it is? So that will give me 4. So that will give me 5 minus 1. I have this very stupid sheep in the house. It makes so much noise. So that will be equal to 5 minus 1. I guess so that will give me 4. Now let's come and look at now we need to calculate our t statistic. T statistic. Here you need to pay attention. My t statistic. The t statistic we use a formula. This particular formula here is t equal to r with the square root of n minus 2, all divided by the square root of 1 minus r squared. Now, watch carefully how we enter formulas like this. This is a mathematical formula. That's what we use to calculate the t statistic. Watch carefully how we enter them. So we start with the equal sign here. So I'll come to this point and put my equal sign there. Then we'll put the top values first, bring our equal. And so the top values first, what are we starting with? R. What is our R? We've calculated our R, which is here. All right. And then our R is being multiplied by bring our multiplication sign there by the square root. In R, square root is like this, SQRT. So the square root of n minus 2. So n minus 2. So our n is 5. Remember, our n here is 5 minus 2, the ordinary 2 here. And then we close the bracket up. Then everything divided by, so we bring this forward slash, that is our division sign, divided by the square root again. So we have our square root, enter again, of 1 minus r squared. Check, it's going to be 1 minus r squared. The r squared, we need to, because we are squaring it, it's important to put it in a separate bracket. So I'll open a bracket again. And what is my r? My r is here. And then I will press my shift key down and 6 to get the squared. Then I'll close it up and close it again. And that's all. I've entered the entire formula. If you can't see it well here, check on top over here. Then you will see what it is in the formula bar. You can see the formula is properly written over there. When you are done, tap enter. And then this is going to give me my test statistic. And then this is my test statistic over here. Then the next thing is to now calculate my p-value. My p-value here. And then the p-value is always equal to t distribution, the two tail. So simply just pick that one. It's already a function in Excel. So it will ask you of my t statistic, which is the x here. So I'll simply put my t statistic over there. Then my degree of freedom. Degree of freedom, I've already calculated, which is 4 here. Then we just close it up and tap enter. And so my p-value is 0.00 something, which is way less than 0.04. This means that the correlation that we have seen around here is very much significant. Yeah, the model is very significant. And then in that order. So for instance, if we had displayed it like in the form of the chart, if we had done a chart and then we added a trend line, we come to add our equations. Let me come, I'll display the equations here and there like this. Then this becomes a very important. So somebody will ask a question. So if your R squared, your model is around 98%, are you sure this is significant? Yes. Now, what is the p-value? The p-value is 0.00 something 26. So this is how we actually do correlation And I hope this has been helpful. You can try all the method, but to in a much more scientific way, you must make sure you calculate the p-value. And I've just shown you how to calculate the p-value. You need your n, that's the total number of samples in each group. You are not summing them up to make it 10. No, they are 5, so it's 5. Degree of freedom, n minus 1. Then your test statistic, you use this formula, be able to insert your test statistic, then you calculate your p-value as shown, and then you're good to go. Thank you, and I'll see you in another video.